सर ॲप्लिकेशन ऑफ डायमेन्शनल ॲनालिसिस किंवा ॲप्लिकेशन ऑफ डायमेन्शनल इक्वेशन हे आपण बघू. So there are three applications. First is to check correctness or preciseness of physical equation. म्हणजे दिलेले फिजिकल इक्वेशन करेक्ट आहेत का किंवा त्याच्यामध्ये जी प्रिसाईज व्हॅल्यू पहिली जी व्हॅल्यू दिलेली आहे ती करेक्ट आहे का नाही ते चेकआउट करण्याचं काम कोण करतं? हे डायमेन्शनल ॲनालिसिस किंवा डायमेन्शनल इक्वेशन्स करतात. तर हे पहिलं ॲप्लिकेशन. त्याच्यानंतर दुसरं टू फाइंड ऑर डिसाइड conversion factor for interconversion of unit in different system of unit. For example, MKS is converted into CGS or CGS is converted into MKS. So MKS can be converted into CGS or CGS can be converted into MKS. So this is second application of dimensional equation. And third important application, derivation of simple equations. Okay, derivation of simple equation, that is to create or establish a relationship between related physical quantity. So in this session, one physical quantity in this application, one physical quantity is correlated with another physical quantity. So this is third application of dimensional equation. Okay, so write down. In first application we have to check whether that equation is correct or not. Okay, so first application of dimensional analysis is to check correctness of physical equation. So this is the physical equation, v square is equals to u square plus twice as. So we have to check that equation is correct or not. So we know that v square, that is velocity square, velocity is distance upon time, again whole square, is equals to initial velocity square, velocity square is equals to initial velocity plus twice into a into s. Okay, so initial velocity distance by time whole square plus twice into a मतलब distance per time square, acceleration. S, what is s? S is the distance. Okay, so what is dimensional formula of velocity? L1 t minus 1 whole square minus L1 t minus 1 whole square plus twice into L, don't take this constant, ignore that constant, L1 t minus 2 in another bracket L1, that is distance, only length is there. So take a separate square, this become this become this, again this become this. We are not taking here, we can take L square t raised to minus 2 plus again n into L, according to law of indices, L square t raised to minus 2 is. Thus each term has same dimension. Here in LHS side, left hand side, L square t minus 2, RHS side again same. In thus each term has same dimension, therefore this equation is dimensionally correct. Okay, so that means each term has same dimension, so this equation is dimensionally correct. Okay, write down. In second application of dimensional formula, we have to interconvert one form of unit into another form to find or to decide conversion factor for interconversion of unit in different system. For example, MKS system is converted into CGS or CGS system may convert it into MKS. Okay. So for example, we have to convert unit of force into from Newton to dyne. So we know that unit of force is Newton in MKS and unit of force is dyne in CGS. Okay. So we have to convert 1 Newton is equals to x dyne. We don't know how much dyne. So we have to find out how much dyne is there. So we know that force is equals to mass into acceleration, that is The dimension of force is m1 l1 t minus 2. We already know this. Then 1 Newton is equals to x die. So put the value of dimensional formula L1 M1 T minus 2. So for LHS we have to take 1 1. For RHS we have to take 2 2. So x is equals to L1 M1 T minus 2 1 divided by L1 M1 T minus 2 for second. So for LL we have to take separate L1 divided by L2 raised to power 1, M1 divided by M2 raised to power 1, T1 divided by T2 raised to power 2. So suffix 1, okay, suffix 1 indicate the MKS, suffix 1 indicate the MKS and suffix 2 indicate the CGS. So in MKS, length is measured in meter. In CGS, length is measured in centimeter. Similarly, in MKS, mass is measured in kilogram, and in CGS, mass is measured in gram. Similarly, in MKS and CGS, time is measured in second. In both condition, time is measured in second. So we know that 100 meter is equal 100 centimeter is equals to 1 meter. 100 centimeter is equals to 1 meter. So put the value of 1 meter here. Then 1 kilogram is equals to 1000 gram. 1 kilogram is equals to 1000 gram. That means 10 to the power 3. We have to cancel out this. And second 1 raised to anything become 1, so we get 10 to the power 2 into 10 to the power 3, and here according to law of indices we are getting 10 to the power 5. So 1 Newton is equals to 10 to the power 5 dyne. So this is our answer. That means in dimensional formula we can convert mks into cgs or cgs into mks. We have to find relationship between them. So that means, for example, 1 Newton is equals to 10 to the power 5. 5 dyne we derive here. Okay. So right now. चला तिसरे इक्वेशन बघू. तिसरे ॲप्लिकेशन. ओके. डायमेन्शनल इक्वेशनचे तिसरे ॲप्लिकेशन. तर पहिलं ॲप्लिकेशन काय बघितलं आपण की त्याच्यामध्ये कशा पद्धतीनं रिलेशन क्रिएट करायचं. त्याच्यानंतर दुसरे ॲप्लिकेशन काय बघितलं म्हणजे इक्वेशन कसे इक्वेट करायचे ते पहिले ॲप्लिकेशन. त्याच्यानंतर एम के एस टू सी जी एस, सी जी एस टू एम के एस बस कसं करायचं हे दुसरे ॲप्लिकेशन. आणि तिसरे ॲप्लिकेशन म्हणजे टू क्रिएट एस्टॅब्लिश रिलेशनशिप बिटवीन फिजिकल क्वांटिटी. एका फिजिकल क्वांटिटीची दुसऱ्या फिजिकल क्वांटिटीसोबतचं रिलेशन आपल्याला क्रिएट करायचं आहे. फॉर एक्झाम्पल एरिया ऑफ सर्कल याचं रिलेशन आपल्याला क्रिएट करायचं आहे. तर कसं ते बघा. We know that area of circle depend on radius. Area of circle depend on radius. More the radius, more the area. Less the radius, less the area. So area is equals to k into r raised to x. We have to find x. So we know that area L square T0 M0. Okay. K, then r L1 M0 T0 raised to power x. We don't know x. By comparing these, if we take a simplification here, so k into bracket L2 M0 T0. So from these two equations, we directly from these two equations, we directly write this x2, x is equals to 2 by comparing power from both sides. L to the power 2 and L to the power x, that means x is equals to 2. So relation is here. So A is equals to k into r raised to x. So A is equals to k into r square. So that means area is proportional to r square. If radius is more, area is more. If radius is less, area is less. But we have to take a proportionality constant here. A is equals to constant into radius square. But experimentally the constant is pi. So area is equals to pi r square. Okay, so area is equals to pi r square. In this way, we can create or establish the relationship between related physical quantity. Here, area and radius are the related physical quantity, and here we establish the area and radius relationship between area and radius. So area is equals to pi time r square. Okay, so this is for circle. Got it?